This video is going to demonstrate hypothesis testing in SPSS. We're using the GSS 2006 dataset to complete these analyses. I will start by demonstrating a one-sample t-test, and then I will also show you how to do a test of mean differences in SPSS. So if you've done this by hand, then you know that we have discussed methods of testing differences in means between a sample and a population value. And SPSS includes a one-sample t-test procedure, so we can do this test. SPSS does not do the test with a z-statistic, which is what you're used to doing by hand. Instead, it uses the t-statistic to test for all mean differences. The one-sample t-test procedure can be found by going to the Analyze menu. Click on the Analyze menu. Then click on Compare Means. Okay. And then you want to go to one sample t-test. Okay. The one sample t-test. This will open a dialog box, and the dialog box requires that you place one variable in the test variable box, and then you need to place a test value in the test value box. Okay. So let's say we're interested in the standard work week for Americans, and the standard work week is thought to be 40 hours. Let's see whether American adults work that many hours each week. So we're going to start by placing the variables hours1, HRS1, in the test variables box. And you do that by clicking that arrow. You can also double click the variable when it's in this box here. Okay, so you have hours1 in the test variable box. Now you need to place a value in the test value box. We want to know about the number 40 because we want to compare American adults' work per week to the number 40 to see if they're working 40 hours a week. So we're going to go ahead and type the number 40 in the test value box. And then I want you to go ahead and paste your syntax. It'll open up in your syntax editor. So you can see we're going to run a t-test. Our test value is 40, and our variable is hours1. Go ahead and highlight your syntax and run it. And let's take a look at the output. You're going to see two boxes of output, and it's not a lot of output actually. It's very simple output. So there's the first box here, and its header is one sample statistics, and this is going to tell you the total number of people who answered the question about our variable, so the number of hours worked per week. We have 2,739. It's also going to give you the actual mean for these individuals, and the mean is 42.08. So you can see that that mean is higher than the number 40, which is the number we're comparing it to. It also gives you the standard deviation of 14.232 hours, and it provides the standard error of the mean, 0.272. You'll also see the second box where it shows you the one sample test. And here you can also have a reminder of your test value equals 40, okay? And here is where you can actually look at your analysis. So you want to look at the value for the t-statistic, which is right here. And the value here is 7.635. 7.635 for your t-statistic. You'll see the degrees of freedom is 2,738, and that makes sense because you have one sample, and you calculate degrees of freedom by taking your n and subtracting 1. You can see here that SPSS always runs a two-tailed significance test, and let's say that our alpha is 0.05 and we're looking for a significance level that's less than 0.05, so this is your p-value. So this column right here that says sig two-tailed, This is your p-value, okay? And 0.000, this is rounded, of course, this is less than 0.05. SPSS also gives you a 95% confidence interval for the mean difference between the test value and the sample mean. So here you can see the confidence interval runs from 1.54 to 2.61, providing estimates of how much more than 40 hours per week Americans work. So it could be as little as 1.54 hours, so 41.54 hours, or it could be all the way up to 42.61. And you'll see that the mean is right in the middle of those. And so we can safely say that this mean of 42.08 is significantly greater than our test value of 40. And so Americans work significantly more hours per week than 40 hours per week. Let's try this with another variable. Let's try this with the variable SIBS. This is the variable that tells us the number of siblings each respondent has. So let's go back to our Analyze menu, go down to Compare Means, and we're going to do a one sample t-test. Okay, we're going to put hours back, and we're going to change our test value. So go ahead and get the variable SIBS. Place that in the box for test variables. And now you need to think about a hypothesis here for your test value. So let's put a test value of 2. So that's 2 siblings, which would be 3 children. Okay, and so let's say we want to know if Americans have a number of siblings that is different from 2. And you can paste that. All right, so we're going to run that, and then we're going to look at our output. So you can see there's 2,988 in our sample. That's how many people answered the question. The actual mean is higher than what I had put for the test value, and it's 3.76 siblings with a standard deviation of 3.178. So you can kind of see there's going to be a big range, and we've looked at this variable before for other examples, so we know it ranges from 0 to 34. Okay, so your t statistic down here is 30.264. The degrees of freedom, 2,987, and you can see here this p-value in this column is statistically significant, that 0.000. It's less than 0.05. The mean difference is between your test value and the mean. So the mean difference in your test is 1.76. And you can see that Americans have significantly more siblings than 2 siblings. So they have significantly more than 2. So you can go through different examples to look at one sample t-tests. I'm going to make another video that shows you how to do tests of mean differences.